Good evening, students. How are you? This is Ankit Joshi. I welcome you all on India's largest e-learning platform, BYJU'S Exam Prep. So, students, this is our YouTube channel, and in this series, we are going to start differential equations. So, this session, the first session, is about first-order differential equations. So, stay tuned for the best of the concepts and to learn first-order differential equation. Let's start. Those who are online, they can show their presence with the help of comments. So, students, first order differential equation. This is the brief introduction about me. I have been teaching in this domain since many years, and my subjects of interest are engineering, maths, signals and system, and analog circuits. Students, one announcement for all of you. Free GATE workshop, 7 golden rules to secure single digit rank in GATE. So students, this workshop is conducted on 16th of May, 7:30 p.m. Yeah, and this will be taken by legendary faculty Abhinav Negi sir, and yes, he is an alumni of IIT Delhi, 10 plus years of teaching experience. Rajshri, start preparing once again as you are in final year now, so this will be helpful for you. So students, let's start. I hope you are all following this. Solve the ordinary differential equation. So all my dear students, I will be explaining you the concept along with the questions. So students, please concentrate here. Yes. So y by x dy by dx under root 1 plus x square plus y square plus x square y square. So I will just try to separate the variables here. So y by x as it is, dy by dx, and on the right hand side what we are doing, we are grouping this 1 plus x square together. From these last two terms I am taking y square common, so again I will be getting 1 plus x square. So on the right hand side we can take 1 plus x square common, so the other part will be 1 plus y square. So this is our y by x dy by dx. Now all my dear students, you can separate the variables. So y, this square root term is brought to the denominator on the left hand side. This x dx is brought to the numerator. So first of all, we have separated the variables. Then we have to integrate both sides. So I am integrating this now. So if you are integrating this, now what to do? I am just adjusting something here. So on the another frame, we are having y in the numerator. This 1 plus y square is written under square root. So when this term is brought to the numerator, its power will become minus 1 by 2. Now on the right hand side, what you are having? Right hand side, x into root 1 plus x square. Root means power 1 by 2 dx. Now student, I am just multiplying by 2 both sides. I am multiplying by 2 both sides. For what reason? Because I want to apply an identity. Now please concentrate. What is the derivative of this bracket? What is the derivative of 1 plus y square? Derivative of 1 plus y square is twice y. So answer of this integration will be bracket to the power n plus 1 upon n plus 1. Bracket to the power n plus 1. N is minus 1 by 2 plus 1 upon n plus 1. What about in this case? See, the derivative of this bracket is 2x. So answer will be this bracket to the power n plus 1, 1 by 2 plus 1 and denominator is also 1 by 2 plus 1 plus some constant c. So 1 plus y square, 1 minus 1 by 2. This power will become 1 by 2. 1 by 2 means root. And in the denominator you are getting 1 by 2. So 1 by 2 in denominator means it is 2. Then 1 plus x square. 1 by 2 plus 1, that will be 3 by 2. And in denominator you are having 3 by 2. It means it will be 2 by 3 plus some constant c. So this is the required solution. Sir, which identity we have used here? I'll just explain that. If you are integrating, we are having a function f of x whose existing power is n, and f dash x, that is the derivative of this bracket, is just written adjacent to this. फंक्शन की पावर n है, फंक्शन का डेरिवेटिव उसके एडजेसेंट लिखा है. सो आंसर विल बी दिस ब्रैकेट to the power n plus 1 upon n plus 1. So this is a very important formula to calculate integration. Can I have a response on this? Let's proceed. Now see here. Solve this differential equation. In this type of differential equation, what we are going to do, here we are having a function of mixed function of x and y. So what you need to do, you need to substitute this 4x plus y plus 1 as a new variable v. Now what to do next? What is the independent variable here? Independent variable is x. So just differentiate this with respect to x. Differentiate with respect to x. So derivative of 4x will be 4. Derivative of y will be dy by dx. Derivative of 1 will be 0. And derivative of v will be dv by dx. So dy by dx will be dv by dx minus 4. So substitute this value in the given equation. Let us say this given equation is equation 1. So this dy by dx is dv by dx minus 4. And on the right hand side, what about this bracket? This bracket is nothing but v. We have substituted this bracket as v. So this will become v square. So dv by dx equal to 4 plus v square. Now you can separate the variables. dv upon 4 plus v square. And this is our dx. Now integrate both sides. So we are having a formula for this integration. It is 1 upon 2 tan inverse v by 2. And this will be equal to integration of this 1 will be x plus c. Now simplify this. So tan inverse v by 2 will be 2x plus 2c. So v by 2 will be tan 2x plus 2c. What is this v? V is 4x plus y plus 1. And this 2 is again cross multiplied on the right hand side. Twice tan 2x. And 2c is assumed as another constant c1. Is the required solution. Chali, come on. Hit the like button if you have not done so. I request all of you to stay tuned. Let's go through this. So this equation is not variable separable form, but this can be reduced to variable separable form. So this is an equation which can be reduced to variable separable form. See this question. Cos x plus y dy by dx equal to 1. So what we are doing, dy by dx equal to 1 upon cos x plus y. Now what can be done? Put this x plus y equal to v. Differentiate with respect to independent variable. Independent variable is x. So 1 plus dy by dx is dv by dx. Comfortable? Alright. I'm not getting your responses. So what is this dy by dx? This dy by dx will be dv by dx minus 1. So do this entire substitution in this equation number 1. So this dy by dx is dv by dx minus 1. And yes, on the right hand side we are having 1 upon cos v. Alright. So now students, this we will be separating the variables. So dv by dx, this minus 1 is brought to the other side. Now take the LCM on the right hand side. Now you can separate the variables. Separate the variables. Cos v upon 1 plus cos v dv and dx on the right hand side. Variables are separated. Integrate both sides. Okay, sir. Now what to do? I am doing a little adjustment here. I am adding 1 and subtracting 1 in the numerator. Then what? I am separating the terms now. So 1 plus cos v upon 1 plus cos v. That will be 1. Got it? Now, integration of 1 will be v. I'll just do certain more adjustment. Integration of 1 dv minus, see this, 1 upon cos v. Arey bhai, 1 plus cos theta, 2 cos square v by 2. So 2 out, 1 by 2, and cos square v by 2 in the numerator, this will become sec square v by 2 dv equal to dx. Now you have standard formula. Go ahead. Integration of 1 will be v minus 1 by 2, and this is simply tan v by 2 equal to x plus c. Now what is the value of v? V is nothing but x plus y. Go back, पीछे देखो पीछे. So v is x plus y. V is x plus y. So v is x plus y minus 1 by 2 tan x plus y by 2 equal to x plus c. So all my dear students, this x and x gets cancelled, and finally you will be getting the value of y. So y equal to 1 by 2 tan x plus y by 2 plus c. So this is the answer. Comfortable with this? Let's proceed. Solve this ordinary differential equation. So students, here we are doing little bit adjustment. x plus 2y is grouped together. From the denominator, from this 2x plus 4y, I am taking 2 common. So x plus 2y plus 3. Now what you need to do, put this x plus 2y equal to v. Differentiate with respect to x. So dy by dx will be dv by dx minus 1 and divide by this 2. Correct? Am I audible? Hello. Good. Thanks for your response. Thank you so much. So students, this x is brought to the right hand side. So 2y plus 1 by 4 log, okay, thank you. 2y plus 1 by 4 log 4x plus 8y plus 5. This x is brought to the right hand side. So 2x minus x will be x plus some constant c. So this is our final answer in this case. Depending on the options, further you can proceed. Let's proceed to the next. Series question. Solve the ordinary differential equation x sine y by x dy equal to y sine y by x minus x dy. So this is a homogeneous differential equation. Now see, this dx is brought to the denominator and the right hand side term is y sine y by x minus x divided by this term x sine y by x. So y upon x, sine cancelled, minus x cancelled, 1 upon sine y by x. So students, this is my equation number 1. What you need to do? You need to put y by x equal to v. So y will be equal to vx. This implies dy by dx equal to v plus x dv by dx. Got it? So do this substitution in this equation 1. So dy by dx is v plus x dv by dx equal to y by x is v and 1 upon sine y by x is 1 upon sine v. So this v and v gets cancelled. Separate the variables. Sine v dv minus sine is brought to the left hand side. Dx upon x. Integrate both sides. So integration of sine v is minus cos v, minus minus plus log x plus some constant c. What is this v? This v is nothing but y by x. So this is the required solution. Just go through it. See this question. 1 plus e raised to x by y plus e raised to x by y 1 minus x by y dy by dx. So students, what we are doing, 1 plus e raised to x by y, this term is brought to the right hand side. So e raised to x by y, 1 minus x by y will become x by y minus 1 dy by dx. Now separate the variables. So dx by dy, then e raised to x by y, x by y minus 1, and this term is brought to the denominator. Now what can be done here? Put x by y equal to v. So x by y equal to v means x equal to vy. So dx by dy equal to v plus y dv by dy. Put this in this equation 1. So v plus y dv by dy equal to e raised to v minus 1 upon 1 plus e raised to v. Now what can be done? Separate the variables. See this. This is v e raised to v minus e raised to v upon denominator is 1 plus e raised to v, and bring this v to the right hand side, minus v. So y dv by dy, right hand side, v e raised to v minus e raised to v upon, see this denominator, 1 plus e raised to v is the LCM. So 1 into v is minus v, and e raised to v into minus v is minus v e raised to v. So these two terms gets cancelled. Separate the variables. So 1 plus e raised to v brought to the numerator, dv is there, and this minus is taken common on the right hand side, dy upon y, and this v plus e raised to v is brought to the denominator. Now integrate both sides. So we can say that derivative of denominator is available in numerator. What is the derivative of this denominator? Derivative of v is 1. Derivative of e raised to v is e raised to v. So 1 plus e raised to v dv is the 1 plus e raised to v is the differentiation of denominator. Answer will be log of denominator minus integration of dy by y is log y plus an appropriate constant will be log c. So if you take anti-log, you will get v plus e raised to v equal to c by y. Correct? What is v? V is x by y. So x plus y e raised to x by y equal to c. This is the answer. This is the required solution. See this question. The solution of differential equation dy by dx equal to ky, where y of 0 is c. Okay, so students, dy upon y, this y is brought to the denominator, and k dx. Now integrate both sides. So this is log y equal to kx plus log c. So this is log y by c equal to kx, taking anti-log. So y will be c times e raised to kx, correct? Okay, sir. So this y means y of x. Now, what is the initial condition given? It is given as y of 0 equal to c. Acha, they have given you c, so we cannot use c here, right? So I cannot use c here. I must use some other constant. Say it is k1. So y by k1 got it. Now apply the initial condition. So y of 0, put x equal to 0, so k1. So k1 is equal to c. So we have got the value of k1. So k1 is nothing but c. So equation 1 is saying that y equal to c e raised to kx. Now see which one is the answer. C e raised to kx. Y equal to c e raised to kx. Option C? Yes, sir. Option C is the correct answer. So that's all from my side in this session. In this session, today's session, we have covered variable separable form, equations reducible to variable separable form, and both the forms of homogeneous differential equation. In tomorrow's class at 10:30 p.m. we will be covering linear differential equation and exact differential equation. Okay. Okay. Thank you. So students, these are our previous year achievers. You can see All India rank 5, All India rank 1, and All India rank 4, and many other ranks from our platform. So wishing congratulations to all these achievers. You could be one among them. Wish you all the best. Jai Hind, Jai Bharat.